Hello everyone, my name is James Bryant and today I'm going to be going over our findings from our internal quality investigation that we held in the wheel hub assembly. So let's go ahead and jump on in. So as everyone here knows, the customer did send us a complaint. It was Rosewood Bicycle Incorporated. They're noting a problem saying that we need to dramatically improve the quality level of our parts. The parts in question is the wheel hub operation, so we'll delve more into that here in just a moment. And starting immediately, we are going to be collecting more statistical data to address this problem. So like I stated, the product in question is the hub assembly. Now, let's go over what the hub assembly is. It's made out of a chrome moly steel, and the dimensions that the customer is requiring us to make this at is 0.750 inches or 3/4 of an inch in diameter. And then the actual dimension in question is the 3.750 or 3 3/4 of an inch in length with a tolerance of plus or minus 5 or 0.005. My apologies. So the plan of action that we came up with at the beginning of this process is intensifying the product inspection, and we're going to be using go and no-go gauges for every single part. And this is probably a process that we are going to apply and keep for the foreseeable future. This way that we can eliminate any parts escaping to the customer, because we do not want to lose any of our business just because of a slight oversight or something getting out. And when we can control it, let's control it. The quality team and myself also we're going to be running an internal quality investigation, and we were able to collect data, and the sample sizes that we picked were picking out 6 hubs 24 times a day and then collecting our data and going from there. So here is what the data is going to look like. As you can see, we split it up into 24 lots where we had 6 total parts in each one. We took the lengths and we wrote them down and plotted it out on this. Note, I'm not going to be showing you every chart that we made like this one. I'll be showing you the key charts, but you don't need to see every teeny bit of information. I just want to give you the importance. So this right here is the histogram that we made to sort of let you visualize what's going on. So according to this histogram, we were able to hit a mean of 3.749, a median of 3.750, a mode in 3.749, and our range is 0.029. We'll get more into that number here in just a minute. And you can see clearly that the range, mode, median, and mean are all labeled. You have your key in the corner up there. So if you want some time, pause this video real quick, take a quick gander, and look at the data here and fully understand it before you move on. So going into our findings from day 1, we noticed that the range is really bad because when we are talking about these parts, we have a tolerance of plus or minus 5. So we have a range of 10. So starting from 3.745 up to 3.755. That's where we're good. And we are hitting well above that, and that's unacceptable. We were also able to find that 39.58% of parts were going to be outside of tolerance, while only 60.42% are going to be inside that tolerance. Again, that's unacceptable, and we here need to address this because we are dedicated to our customer. So obviously we need more data than just from one day. So we sat down, we decided to go ahead and combine days 1 and 2, compare them and see how the data changes. And while we were doing this, we also decided to create flowcharts of the process of the part moving from operation to operation, and also doing a cause and effect chart to lay out some potential problems that would cause these quality issues. So that way, rather than just putting a band-aid on it, we can actually get to the root of the problem and come up with the best solution to the problem. So right here, you're actually going to be looking at the X bar and the R charts from days 1 and 2. And you can take a moment to look at these. The one thing I am going to note is that your range is obviously out. It's reflected in these charts. But also something else to note is how chaotic these charts are and how far away majority of the points are from zero, or your center line. It's just a chaotic mess. And it's also reflected in our histogram chart as well. This is actually a histogram of days 1 and 2 combined, so you're actually seeing every single point. And if you note, it looks like we're hitting dead on in the middle. If you look right in the middle, you have 32 parts that are hitting at 3.749 and 12 at 3.750. That's where we want to be. However, if you look a little bit closer, you can actually see the further and further we go, the more and more parts, especially on the low end, because we have, starting at 3.744, we already have 14 parts that are out of tolerance. And that's even one part's bad, and we already have 14. So obviously the issue. So to go over our day 2 findings, we, like I just discussed, found that the charts reflect chaos, and we noted that only 7 points fit within the range that we were just talking about earlier. And note that whenever I'm talking about range in this specific instance, I'm going between the plus or minus 5. I'm not saying equal to the 755 or the 745. The main reason why I'm saying that is because as a company, we need to shoot for hitting that nominal number every time rather than running at a number that may hit tolerance, but it is so close that it makes it harder for the rest of the process to keep it within tolerance if it recuts it again or something like that. So that's why we pick these numbers. The histogram also shows that there was 77 total parts that are out of tolerance, and a percentage of that is 26.7. But not all was bad news on day 2. We were actually able to make a discovery. We picked a random operator, or an operator at random, excuse me, and we picked a machine at random that runs these parts, and we observed the work process while we were making our flowcharts. And we discovered something about the operation itself. So to go into detail about how this operation is done, every 18 minutes, the operator measures the length of 6 hubs on the micrometer. The length values for those 6 consecutive parts are averaged, and the average is plotted on a charting paper. Then the data is reviewed periodically by the operator, and then that allows him to decide whether or not he needs to make adjustments on these parts. And these adjustments can be made by loosening up the clamps and moving in the cutting tool in and out depending on his average. And this can take about 5 minutes, and it seems to be happening pretty frequently. This sounds like the operator is over adjusting his parts, and that It just slows everything down, and it affects your speed, and it also affects your quality because you don't have that much control because you're touching it and moving it so much. You're not taking into account the wear of the tool or little things like the material strength and everything like that. So what we asked the operator to do for our third day of the investigation is to make no changes in the machine for these parts. So that way we can see if this is what's causing the problem or if it's grasping at straws. So here again we have more X bar in our charts. These are actually day 3, and yes, they do seem as chaotic as the others, but if you do look closer, you will see that the numbers are getting closer and closer to that center line, and it's becoming more predictable, I think is the best word to say. So we also went ahead and made ourselves a new histogram chart. This is just for day 3, not including days 1 and 2. So this is just day 3. And overall, you can already see that there's a difference. On each end, there's a lot less that's falling under the 3.744 and 3.756 and so on. So all in all there, that's already significant improvement. So the results of day 3 is improvements all around. And to put actual numbers to it, as you can see, we had only 11.8% out of tolerance and 88.2 intolerance. That's a significant increase in good parts at the end of the day. We were also able to eliminate that excess 5-6 minutes per 6 parts to make these adjustments and everything and overhandling of the part. So it just makes the process quicker and you're able to get stuff done quicker, bringing more money to the company. So to wrap everything up, we're now going to be starting to head in the right direction for us as a company and for the customer, getting them the parts that they need at the measurements that they need. However, just understand continuous improvement is around. We're always going to be improving, and we're hoping to get these numbers even higher, maybe up to 90, 95, 97, even get it up to 100% if possible. And I know it's possible. And we were able to discover the root of our problem, which was overhandling the part, thanks to not only the data that we were able to find, but also the charts that we made, the flow chart and the cause and effect. The team worked together to find a solution that helps the company. So, all in all, I want to thank you for listening to this and thank my team for building this, and I hope you were able to learn and enjoy.